Welcome to Passive House Live, Construction Tech Edition. I'm Kevin Brennan here in New York City. I'm on the road traveling to Southern Jersey to look at a project for a family friend. But what we're really here to do is get nerdy with Marcel Studer from Econ Group. He's a good friend from across the other side of the West Coast, but I've developed a relationship with Marcel over many years by admiring his amazing work. He's a builder, an architect, a passive house enthusiast, a teacher, a trainer, and an all-around expert. And I'm so glad that he's going to share his expertise and some amazing knowledge and some cost optimization and some all fun, tricky details on the things that really matter in passive house. So he's going to break down the nerdy stuff. I'm going to be here being a passive house nerd, and I'm going to kick it over to my fellow co-host. Thank you. I'm excited.
Awesome. Thank you, Kevin. Welcome, Marcel, and happy Halloween, my geeky friends. Today it is all treats, no tricks. I was going to be a Phillies fan, but I'm fickle because we lost last night. So I did the Texas two-step, and I'm Jessie, the cowgirl from Toy Story, headed to FiesCon. It was a quick pivot. So what did we do this month? We went to some conferences. We had met a community of leaders and a larger community of new curious minds, because after PHN, we went to EBA, which is the High Performance Builders Conference. And I shared a poll, do you have an air boss? 1 was yes, 2 was, what's an air boss? So there were more 2s than 1s, so help me out and spread the word. And the other news is Mary James. Wow. Check out phase 2 of her Inside a Passive House Experts do-it-yourself retrofit. I'm going to throw a link in the chat. It's amazing. And let's go beyond marketing, people. Let's go to reimagining, rebooting, and rebuilding our industry with Marcel today. I think I'm going over to Mark.
I tell you what, Kevin's is not a costume. He really always is geeking out about construction. And guess what? Shannon's not a costume either, because she's trailblazing everything passive house. We'll get to Sean's next. I know he also has a chain, which we may or may not see. But one of my favorite things about Marcel is he tells fairy tales. And that's fairy tales with a PH. In fact, probably the best fairy tale I've ever heard in life and in passive house. So like always, I invite people to watch earlier episodes and come back for future with a PH one. My name is Mark Willie. I enjoy the conferences that I've got to see so many of you at, and I enjoy the first, second, third, fourth, and sometimes the 5th Wednesday of the month to see all your wonderful faces. So let's undo the videos. Let's make yourself seen. Let's hear your comments erupt. And remember, fairy tales come true if you plan early with the right team. Over to you, Sean.
All right. Good morning, good afternoon, good evening from wherever you are. Looks like we've got a lively crew across the planet here. So, of course, this is definitely a global show, and love the enthusiasm that Shannon had to make it a Halloween edition of Passive House Accelerator Live. Construction tech, of course, bringing the technical, the technique, and the technology. And here we are with Mr. Marcel. I have so much praise to give this gentleman, being the educator that got me into the tradesperson course and did a marvelous job training, I think we could say, thousands of individuals that are in the construction industry. So Marcel, we are grateful for your time. I think we can say you're now a 3-time presenter on the Accelerator, and definitely, as Mark said, you are a storyteller like no other. And so let's get the party started. It is time for not only your tricks, but we're going to have a treat because we get you presenting. So Marcel, over to you, my friend.
Thank you very much, Sean, Mark, Shannon, Kevin, all those kind words. I'm blushing. You see probably my face is getting a bit more red. That's not Halloween makeup. And my only costume I'm going to put on is some glasses so I can see better. And I look a little bit more nerdy as I start talking about some very technical pieces in Passive House here. So don't expect another fairy tale, but fairy tales can also come true sometimes. And let me just organize my screen a bit here. And thanks to everyone for joining us from lots of different places. We got over 110 people here. Makes me nervous. I never had that many students in a class. Let's get started here with some of my slides. So I'm gonna talk about thermal performance, and particularly in a wall assembly that most of you are familiar with an exterior insulated wall. And we're gonna particularly look at some of the details around facade attachments and also window installation. And these are kind of lessons learned on our latest project here in North Vancouver, where I'm located in Canada. First, though, a little bit of an overview, a little bit of a holistic view on building performance and optimization before we deep dive into those two specific pieces. So I'm all familiar with the 5 principles of Passive House design, and definitely the starting point to where we design to high performance buildings, but there is more to that than just those 5 principles. We all realize that. And it starts with the design piece, where we have influences from the programming, the functions of the space we're designing, the requirements, site conditions, setbacks, surroundings that are dictating the shape of the building, architectural, artistic expression. The architects are artists in a way, and do great jobs in doing amazing buildings that are aesthetically pleasing. Code requirements come into play. We need to stick to the local quotes, and also structural design. Building has to stand up. There's certain spans we can do with certain materials. So that's all kind of a given in the design. Once we start to add in the environmental considerations, maybe we start looking at optimizing form, minimizing that heat loss area proportionally to the heated volume. And what Passive House is really good at, reduction of the operational carbon with high performance envelope and efficient low carbon fueled mechanical systems. Taking it further and looking at the embodied carbon as well, big discussions going on around that currently everywhere. And that really ties into a conscious material selection. The end goal, what we're working for, is thermal comfort, indoor air quality for the occupants as well. Never forget about that. It's not just about energy efficiency and carbon neutrality. It's about comfort and health for our occupants in our buildings. With that comes a social consciousness as well, and resilience in the face of climate change, getting some material selected, some mechanism into withstand some of these events or be more resilient in events that are climate change related. The third piece I'm going to add in there, and it's always a bit the elephant in the room sometimes, especially when you're a geeky Passive House nerd, is the cost, right? In the end, these buildings have to be built. They have to be economically viable. Otherwise, we don't stand a chance to get, the love of Passive House out there. We need projects. So breaking that down into planning costs, and yes, high performance buildings may have a higher planning cost because a lot of it gets done upfront, and that's a good thing. So there's consultant fees, permit fees, etc. Then the actual construction costs, breaking that down in labor and material. Don't forget about equipment, cranes, scaffolding, anything like that. And also construction administration costs. Building operation cost has to be included as well, especially when we're building buildings that are lasting much longer. We're looking at that entire life cycle cost more. And that would be, the building under operation. How much do they pay in utilities per month? What are the maintenance costs? What are the replacement costs of some of the equipment components? And what is the end of life cost? How much does it cost to recycle a building or rebuild it or tear it down? So keep that in mind. And that's really just kind of the bigger picture. And we're all working within those three kind of optimization parameters every day and struggling with some of them, I'm sure. That's part of the challenge of going into high performance building and doing something that's maybe not quite the norm yet. So I'm going to focus on this little project. I'm not going to show you any pictures more than my little design pH model here. It's situated on the slopes of the North Shore Mountains in North Vancouver. North Vancouver has an ideal orientation to the south. The slope is from the north to the south, so we're really kind of opening it up for solar gains on the south side. This is closer to the forest, so there's a lot of mature trees on the site. You can see that. And also the local zoning is a little bit old-fashioned, I would say. So it doesn't allow for a just double-story high building without the upper story being set back. So we call this here the wedding cake design that gets kind of forced in by zoning. So these are just some of the parameters around the design that dictated the shape of the building. So we had to work with that. There's only 2 stories. There's no basement. So the form factor isn't ideal. So it forced us into looking at some areas where we can optimize the passive house model, our wall buildups, and breaking it really down to the window installation and the facade attachment. So we decided on an outboard insulated 2x6 structure with 6 inches of mineral wool with obviously some high performance passive house windows. So we got to look closely at exploring a few options for the facade attachments and kind of the thermal performance and the cost behind that. And then also looking at how do we install our windows in a way that we can make the model a little bit better in terms of heat loss and thermal performance. So first, looking at the facade attachment, and this is an assembly we've been working on since 2008 with the very first passive house prototype we worked on locally here, and it was only 3 inches of exterior mineral wool at the time. So it would probably be a low energy building if we would certify that now. But we already had to, we already found, someone is unmuted there, okay. We already found some mineral wool, which wasn't that commonly used for thermal insulation at that time. It was a special order through a more commercial supplier of insulation. Mineral wool comes more from the industrial insulation side, but made its way into thermal insulation. So, and this time we used screws, and screws became kind of the go-to for attaching through insulation. And we obviously went with higher layers for higher amount of insulation, more layers for passive house buildings. So we've done 6 inches up to 8 inches of exterior mineral wool with screws. Clips came into the market, so we started experimenting and using some of these. So I'm going to get into those 2 that we worked with a little bit more. But first, the question really is, what is the most effective way to attach your facade through outboard insulation back to the structure? That's what we explored for this particular project. And again, it depends, like so many things in passive house, because it's a performance-based standard. There's not a recipe, tick the boxes kind of approach. There's a lot of different ways to get to the same result. So in the end, the weight and the type of facade is key. We got that dead load. We also have wind load, so that will play into that as well. Then how deep is that insulation layer? That will affect the attachment. And the type of structure behind it as well. So is it a mass structure where we can just attach a clip anywhere, or are we tied to the spacing of our structural members like a stud wall out of wood or metal? And then the thermal performance goal. I mean, you all know some of the classic approaches of doing this with the sag girts and metal going straight through our insulation, creating a huge thermal bridge and minimizing the thermal insulation effect down to about 30% of its actual value. So obviously that's not what we're going to talk about. So I kind of honed in on our project here. So I picked the 2x6 structure with the 6 inches of mineral wool, and then we have kind of 2 main categories how to do that. One is with structural screws and one is with facade clips. So looking at the structural screws first, structural is the word. I got to look at the structural forces at play here. We got the load of the facade, gravity, we got tension strength through the screw, compressing the bat back. There is some momentum force on there as well. Without getting too technical, we have to figure this out, and there's tables for that, really, to figure out what type of screw, the diameter, what material is it. That plays more into the thermal performance. The screw spacing, vertical and horizontally, and then also the embedment into the structure. So this is, and thanks Kim for posting the links right now. This is one of the first links. If you go to Rockwool's web page, you can get a resource page, and here is a quick table to figure out what is the spacing for our screws according to our weight of the cladding. So there's also a heavy one that I left out for here because we're using a hardy cementitious board on this project. So we'll get back to that. Is also talking about the embedment and the minimum screw diameter. One thing we got to remember that these screws are metal, and there is a potential of long-term creep, so that the gravity will slowly, pull the facade down. And so this is an extreme case that the screw will get bent like that, but this can happen over time slowly. So there is a way to avoid that, and basically we're doing 2 screws in one spot. One goes in perpendicular and one goes at a 45-degree angle up. So we're creating that structure of a triangle, which is really strong structurally, and it will prevent that happening over time. So you do that just maybe every story. You don't have to do that at the same spacing as the other screws. Looking at the thermal considerations, this is a screenshot directly out of PHBP. So you got the wall assembly there, and this is without consideration of the attachment at the moment. So you can see it's R46 imperial or 0.124 U value metric. And looking at 2 different types of screws, I mentioned that galvanized screws or stainless steel screws are commonly used. Stainless is a little bit less structurally sound than galvanized, so you got to run that by your engineer. But I'm just looking at the thermal performance here. We can calculate what's called a U value add-on, and that's based on the amount of screws you have per square meter, and it's also based on the chi value of the screw, which is the thermal bridge factor of the screw. But there's also a handy little calculator that friend Andrew Peel, Peel Passive House, has put together, so where you can get a U value supplement quickly rather than having to go to the lengths of doing a chi value model in a thermal bridge modeling software. So stainless steel screws, better. You see the supplement is less. It's 0.002. Galvanized, 0.005, same spacing, 16 inches on center in both directions. And that results in a adjusted U value now of 0.126 or 0.129 with the galvanized, or R45 or R44. Now, that's all good. We got the technical part out of the way, but what about the constructability? This has to work on site, right? And we have experimented a lot and have a lot of experience with putting on these outboards, insulation pieces and screws. So I'm just sharing a few of kind of the main topics that we came across. So that embedment issue, fastening into the wood framing members, can be quite difficult if you're going through 6 or 8 inches of insulation, finding an 1.5 inch face of a screw. So that we spend a lot of time in the beginning laying it out properly, pre-dealing strapping, so we're screwing in straight. But you can actually, and this is straight out of a study by RDH, which is the second link that's on there, you can actually upgrade your structural plywood to 3/4 inch, and you get, depending on the weight of the cladding again, you get similar load deflection performance than well, when you would hit the studs. So you can get away with that. So definitely I would do that now rather than just spending a lot of time trying to find the studs. Sequencing is always an important piece of construction. If we're using a mineral wool insulation, the WRB, the water resistive membrane, the blue Siga my vest you see here is behind the insulation. If you're using wood fiber, I will put it on the outside. In the end, there is a sequencing approach to that, and also holding those insulation panels in. If there's more than one layer, you can't just use the strapping right away. You got to start layering those panels. So there is some temporary fastening involved as well. So you're adding in some more fasteners and some more work to do this. The compression of the insulation, the mineral wool comes in different densities. And even if you go with the highest densities and you're screwing these bats on, you're going to get the compression. The bats are going to get sucked in to the insulation a bit. So you have to start shimming that a little bit or truing that wall before you can install your cladding elements so that they are in the right plane. So higher density panels are heavier. They need maybe more lifting equipment on site. It takes a bit longer to work with them. So there is some higher labor cost and equipment cost there. And then there's also an up price in the material itself for a higher density insulation because there's more material in it per panel. Last one is what do we select for strapping? This is a wood construction building. Of course, it go metal as well, but it is recommended to maybe use a more stiff strapping that doesn't deflect as much, again, because the compression of the insulation. So we actually, in the screw approach, we use a 2x4 strapping rather than a 1x4. Okay, let's put that together, and that's basically a cost analysis percentage. I know we have people from all across the world. I don't want to bore you with our loony Canadian dollar. So I basically just looked at the percentage and I only looked at kind of the additional material and additional labor plus the cost of the fastener itself. And that's per square meter. So that's including how many fasteners are in a square meter. And then some additional material costs needed to get to this approach, and then the labor. So looking at the galvanized versus the stainless steel screws, I used the galvanized as the baseline. The increase of 10% in cost comes solely from the stainless steel screw. So going from a galvanized screw to a stainless steel screw is more expensive. So we can see that here, that's pretty straightforward. And then also a summary of the thermal performance, plugging those adjusted U values into the PHBP. It made a little bit of a difference between stainless steel screws and galvanized. You can see there's a 0.2 kilowatt hour per square meter per year difference, or equal to 1.5%. Great, let's move on. Let's look at the clips. And I selected a local made clip first. We've used in the past fiberglass, a very low conductive material clip by Cascadia. It's a very great product, really designed more for commercial applications. Generally clips are, but I wouldn't shy away, even in single family construction, to try some of these things out. And that's what we did exactly on this project. The other one we looked at is a stainless steel clip imported from Austria by eShot, and you can see it's got some funky little pieces going on. It's got this tension rod that's going up on an angle. We'll get into that a little bit more. So looking at Cascadia, it actually technically is not a clip. It's actually a thermal spacer, you know, a thermally broken spacer or a low conductive spacer made out of fiberglass. If you're installing this commercially, you're still using screws going through fully through the clip. So looking at that thermally, we're back to the screwed approach, right? I'm not going to say we're screwed, but we're back to using screws and the same kind of performance that we have with screws. So I'm not going to show you that, because we can in the residential single family use the spacer as a clip. So we're just attaching the flange to the structure and then attaching the strapping to the outside flange without having screws going through this spacer clip. So with that, obviously you got some diminished structural qualities. So we're looking at a spacing of 16 inches horizontally and 24 inches vertically, which would be 4 clips per square meter. Looking at the Austrian import E-shot, and this is a model called Crossfix. It's stainless steel. It's got a little plastic, thermal break in there when you attach it to the substructure. It gets used a lot on top of concrete, steel structures, highly conductive structural materials. We used it on top of wood, so it still works. It has holes for screws. You use wood screws rather than, you know, anchor bolts. And then the key piece is that what they call the power key, which is a strap that creates that triangle again that we looked at before, which is such a strong structural shape. That allows for some adjustment also of the clip in the vertical plane, and it makes it much stronger. So this is actually a screenshot of the email that our structural engineer sent us for this project. And he's saying that we can change the spacing of the clip to 32 inches horizontal. So now we're going every second stop and 48 inches vertically. So now we're only using 1 clip per square meter. So we're going from 4 to 1. This is key, right? This is minimizing the thermal bridging effect. We'll see this on the upcoming slides, minimizing the cost as well. So talking about thermal consideration, I used the same calculator for the fiberglass, maybe not quite the right approach, but I couldn't find any data on the Cascadia clip by itself without the screws. So I know it's a very low conductive material. It's got a lambda value of about 0.054. So it is almost like an insulated material. And so the bridging effect is very minimal if you don't have screws going through. So this is not a typo. There is an additional 0 in there. So 0.0005 as an add-on to the U value. Obviously stainless, not so much. Thermal conductivity of about 17. And these clips, we have a certificate from Passive House Institute showing the chi value. So super easy to plug that in. And it's around 0.009. So already see a big difference in the thermal performance there. So once we adjust the U values again, we get 0.125 or R45 with the Cascadia fiberglass clip and 0.133 with the E-shot stainless clip. There is some constructability pieces again. Because the spacer clip from Cascadia has a wider cross section, it is harder to cut that into the midfield of an insulation panel. So it takes more time to get that tight, and you all know that the insulation has to be tight, otherwise we got some gaps that are thermal bridging again. Also, this clip spacer doesn't really have any adjustability in its steps, so you're relying on the substrate to be really true. So if that's not the case, you're still spending time now shimming between the clip and the strapping. And it can accommodate horizontal and vertical strapping. This may be, you know, depending on your cladding design. And you can use the lighter weight, less dense mineral wool insulation with these clips. The E-shot clip is like a knife blade. You just push your insulation panel right through it. There's very little time spent cutting out the panel. You can adjust in any plane the trueness after all, which is a great piece, and it's just by these, you can see there's a metal angle that needs to be put in. So that's an additional thing we need to do. Because we're going 32 inches on the horizontal spacing, it's too much for our cladding to span. So we had to first put in this metal channel horizontally, and then the wood strapping is tap screwed on vertically every 16 inches. But this channel slots into the clip, and it is allowed to go in and out, move in and out to completely through this plane. And the same is true for the lighter weight, less dense material. So now comparing the four, and yes, we'll see this coming on, that maybe I'll put this on right now. The thermal performance of the e-chalk clip is, the overall is giving us the kind of lowest, but, or the lowest in terms of not being the best, but it is a great cost saver. So we have to the baseline, to the screws even, we have a saving of about 25. And that has all to do with the amount of the clips or fasteners, because we're only using 1 per square meter compared to 6 for the screws and 4 for the Cascadia clips. So it really dictates the price there. Now, I'm not saying you should pick one or the other. This is just showing you kind of what you can do or should do before you start designing this this critical piece of your envelope. And if you really want the lowest heat loss, the highest performance, you would obviously pick the Cascadia clip, and it comes with a cost, obviously, but maybe that's what this project needs that you're working on. So we're moving into the second piece, maybe another 5-10 minutes here. So looking at the window installation optimizations, and everyone who is a designer or is involved in Passive House knows that this is probably the single most critical detail that we work on in a building. Everything comes together, all the envelope pieces within the window, and the way the window is attached into the structure, into the assembly, is key in terms of minimizing heat loss. So looking at 2 scenarios. First, a little bit about this project. Again, here you got the same picture, and this is the window schedule. And if I add up all the perimeter of the windows, we're looking at 170 meters or 558 feet of perimeter lengths of these 19 windows combined. So there's a lot of potential there, even in a single family home. There is a lot of linear thermal bridge factor there on the window installation. So the typical way we have been doing this is, because we have a wood structure that's insulated, wood is a less conductive material than steel or concrete. So we get away with installing the window within the 2x4 or 2x6 structure. We don't have to always go to the extent to do more than that. So looking at that, it is a Passive House certified wood metal clad window from Austria. Brand name is SIG. We use that on both projects. So really comparing apples and apples here. So here's just a bit of the assembly. We got a 2x6 structure filled with bad insulation, and then the outboard 6 inches of mineral wool with a vented facade. And the window is pretty much installed flush to the structural sheeting with the outside of the frame. So looking at the thermal performance, the only way we can do this is to model this in thermal bridge modeling software. We got a psi value of 0.0188. That's the linear transmittance factor. And then again, plugging it into the PHPP of this particular project, the specific heating energy calculated was at 14.6. And you all know that 15 is the cutoff. So getting awfully close to that. So this is the reason why we explored further in this case. And I came across this product actually at the International Passive House Conference when it was online. I saw a presentation on this, and it's a fiberglass composite kind of box system to install windows outboard of a structure, really designed again for concrete and masonry structure. but hell, why not use it in wood? And we did. So we bought that system, and there's a lot of more information. There's a link in there as well if you want to get into it. It even has these special clips that center the window for installation. So it was a really nice way of installing this window as well. It actually saved some time in the window installation. Yes, there was more costs to buy the actual frames, obviously, and we're gonna see that in a bit here. So by bringing the window into the insulation plane, this really boosts the performance, as we're gonna see in a bit. So here you see the detail, same kind of build up in the windows or in the assembly, and then just the window installation was done differently. You can see that we also added on some interior insulation here, so we're even boosting that more. That blue piece is XPS. So that really had an effect on the installation as well. So running it through the software again, and we're actually getting a negative psi value. This only happens when you have really, really good details. I mean, normally in a corner detail, junction detail, but we got it with the window. So we're now, we're so good, we're below 0, so it's correcting it down even more. So we're at 0.0036 watts per meter Kelvin for the linear transmittance of this installation. So with that, we brought the thermal performance overall of this project down to 13.8 kilowatts, and compared to 14.6 we'd installed in the structure. So that's a 0.8 kilowatt difference, almost a 1 kilowatt difference. Definitely worth exploring, in my opinion, because that can make a big difference. Say you're compounding that now on a larger structure with even more windows, you're gonna probably see a bigger effect. Just a bit on the cost, and it was in euros, and so US dollar is probably the most common currency everyone can understand a bit, similar to the euro, I guess, now. And so for this project, the overall additional cost for that Studer frame was around $6,500. So it's not cheap, but if you look at it on the grand scheme, it was about $1.85 per square foot, or 0.5% of the build cost. Great. That's really it. I just want to conclude and really focus on these 3 main drivers again that I introduced for the optimization in high performance buildings. So that's really the key. We are all working with these, and the importance of one or the other, we're not gonna argue that. That really depends on the project as well. And so many things are project specific, and you hopefully see it a little bit with the example I showed. So in the end, it's about finding that sweet spot between these categories for each individual building project. That's it. Any questions?
Marcel, beautiful stuff. Let's head over to the sponsors.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors. And I'd also like to quickly thank our newest patron sponsor, Longboard Architectural Products. So thanks to Longboard for joining us.
Excellent stuff. Thanks, Zach. All right, Shannon, I think you've got Kim queued up the questions, so we'll let you manage the question period. And Marcel, great stuff.
Thank you.
Absolutely, Marcel. Thank you so much for that fantastic presentation. It's great to get a feel for the Vancouver climate, the wedding cake style architecture, even the economics of it all, but especially optimizing those three main drivers to find the sweet spot. And I can't tell you how many people I already want to share this comparison between the EGOT and the Cascadia clip with. So for those of you who don't know, we post these videos after we have this live event, and you can share them with anyone, anywhere for free. So please answer the poll that's coming up on the screen right now, and we will dive into the questions. Hang on to your hat, Marcel, your hard hat. Our first question is from Mark Ashby. Mark, would you like to unmute and ask your question live?
I had two of them, I think, but I'll start with Marcel. Hi, great presentation. Thank you. Do you use any other types of insulation for outboard other than mineral fiber?
Yeah, definitely would be open to using wood fiber. Not so much foam insulation, maybe because more of the flammability and also because of the embodied energy and toxicity of the foam products. So I know it's not part of Passive House mandate yet, but really looking at the embodied carbon as well and using more natural materials is definitely something I would embrace. Mineral wool really good, obviously, as a fire separator as well. So that's one strong point. Could argue, in as a resilience. We had a lot of fire. Brandon is Kevin Brennan is the firefighter. We got a lot of forest fires here in BC and in Canada generally this year. So it's a hot topic. What can we do to make our buildings more resilient to that? So that would maybe point more towards mineral wool, but definitely be open for more natural insulation materials as well.
Thanks.
You had another question, is that?
At least one other. Yeah, I was also curious where you are acquiring chi values for screws with different assemblies. Are you creating those?
That would be the ultimate. Yeah, I will model it in a 3D Bridge software. I'm using MoldSim, which has a 3D component, so I can do that. For this, I just use the calculator from Andrew Peel.
Yeah.
Chai, Sai, you say potato, I say potato. You say project, I say project. For those of you who are not familiar with the psi value, we did throw a definition into the chat. Up next is Sean Rose. No, I'm sorry, is Drew. Drew, would you like to unmute and ask your question?
Sure. Good. Hey,
Hey,
great
Drew.
presentation, Marcel. How you doing?
Good.
I was just curious. I think my question was about what the density or compressive strength is of the mineral wool, and then whether different types of compressive strengths or densities, and how you go about choosing which one.
Yeah, so it depends if you're using the screws or the clips. So on the screws, they're relying on that compressive strength, and I think it's about 80 pounds per square foot or something, if I'm not mistaken. The rock wool website or any other mineral wool supplier will have different products and their different strengths. So you want to go for the highest one you can get. I think there's some higher ones out there that are 100 or more. But I think at the minimum, go around 80 or 90 for the screwed approach, because you're relying on that compressive strength. Now, the thermal performance slightly worsens the denser the material is. So it kind of plays against you a little bit. It's not super drastic, but as soon as you start using clips, you can go with a much lighter and less dense mineral wool panel, which is a bit better insulating. So more like a bat almost, but not as soft, but somewhere in between. So yeah, that's how I would select. It depends on the attachment system.
Okay, good. Appreciate that. Thanks.
Thanks, Drew. Great question. And Sean St. Amour, you got a good question in here.
Yeah, well, Marcel, I mean, you've done so many passive house projects, and I was just wondering, have you ever gone back to look at your projects to see if you had any exciting issues or any sagging, and just even seeing like if it's sagged by a few millimeters. Just want to know about, again, you're really good on the technical. I just want to see if you've gone back and looked at the on-site to see how it performed.
I haven't physically measured it, but I've been by all the project I've worked on. They're all in the region, so I either cycle past them or drive past them when I'm visiting other sites. So I haven't seen anything you could, drastically you could see from walking or driving past. But that's a good point. Maybe start, doing a bit more on-site kind of studying as well and see how, what settlement is. In the end, there's a lot that happens with wood in our wet climate, right? So we got a lot of moisture changes happening through the season, especially here on the Pacific Northwest. So that could be that the structure itself, is just doing its thing, or is it the screws or the straps? So it's not always that easy to pinpoint what exactly is moving, but no major issues for sure.
Great, thanks, Sean. And yeah, as we all know, a lot of these building materials, not just wood, move as the temperature rises and falls. So always great to go back and take a look at what's happening to your designs in real time. Our next question is from Zoe, but she asked us to ask it for her. She asks, when you're fastening only into 3/4 inch thick plywood sheathing, that sheathing provides similar load deflection performance to assemblies where screws fasten into the wood framing members. But what about how far the fasteners have to embed into the framing member? Wouldn't 3/4 be too shallow per the tables you provided before? Did that make sense, Marcel?
Yes, so it's 1.5 inches to go into the structure. I guess half of that is the plywood and 1 inch into the structure. It has to do with also the makeup of plywood versus dimensional lumber, right? I mean, you're going perpendicular through some parallel laminated wood members or laminates in a plywood. So that has a different pull-out strength than just going into the side of a stud, right? So that's my understanding. I just know you got to go more into a stud than just through plywood.
You took the question out of my mouth, which was, what about OSB or any built-up plywood? So
OSB probably not as strong as plywood, I would say,
right.
Just because of its makeup. But I'm no structural engineer. I'm originally an architect, but I'm geeking out now.
Keep up the good geek. All right, our next question is from Harvey. Harvey, would you like to unmute?
Hi, everybody. Hi, Marcel. My old,
Harvey,
nice to see you. He was my instructor when I did my Passive House tradesperson course at Passive House Canada. I actually have two questions. The first one was what I put up in the chat. What was the time difference? Was there a baseline with the way you were putting in the screws, one going at 45 degrees and the other one going horizontal? That was question number one. And then question number two was, you talked about the difference of those, the window, was it called Suda or Sola? I think it was, around the window. And there was a difference of 0.8 kilowatts, and it was $6,500. Was there any modeling done to figure out, and I know people don't like this question, but what that payback was, even though it's 0.5% of your budget? I was just curious if that was a consideration that was looked at by you as well as the client.
I'll start with the second. I forgot what you asked first, but you may have to help me. But I thought about doing an economic calculation. I didn't get as far. I mean, I wouldn't just look at simple payback. We never do that when we look at buildings that last a very long time. So I would actually maybe look at either cost of kilowatt hour saved. That's one way, and that's already built into the PHPP. The other one would be to do a kind of cash flow at the start, I forgot what the term is now, but in the beginning of the project, you're calculating the savings you're going to make over the loan period of the project. So 30 years, you have a certain amount of extra money available to borrow to spend on paying for that Suda frame, for example. So that's something I could do, maybe follow-up presentation. I don't know, maybe you can take this further and make it for a conference presentation or something. So thought about it, just didn't really have enough time to get into that. Thanks for doing that. What was the first question? Something about
just as a comment, I guess I look at things, and a lot of people will look at it from a payback point of view, even though you're looking out 30 years or longer for housing. But people were going to say, well, what's the benefit to me by doing it? You're doing a whole bunch of other things. They may look at, people get very funny. Clients get very funny. Well, why this one specifically? Why this little piece at 6,500? What's the issue for it? You can show them a number, but if you show them a number, but if you attach a dollar amount and when that's going to kick into the positive, I think that's the reason I asked the question more so than anything. And I think that's just an easier sell. The first question was the timing of the labor, and I didn't really flesh it out. Was there? I know you're going in at 45 and one at horizontal on the screws that are going in at the 6-inch screws. Was there a mock-up done as well, and how long did it take? The differential, if there's a baseline, regular just going in at horizontal versus horizontal and 45. I'm just trying to understand. I understand the process. I'm just trying to understand how that calculates out during the build.
The 45 screw was only every story, so it wasn't like every spot we attached. So what I looked at is the time difference between the screw approach and the clip install approach. And the each-shot clip definitely takes longer because you got that extra key cross piece. So that was factored into that. But because we only got one clip per square meter versus 5 or 6 on the screws, right? So that's the difference in labor. In the end, that's what it takes 10-15 minutes to install the screw. If you factor everything in, grabbing it, going up on the ladder, putting it in, maybe that's conservative, but I just kind of set that as a baseline and then see, is it going to take longer for a clip like an each-shot one versus a Cascadia one. And back to the overall, cost in this particular project. This was a make or break kind of passive house thing we had to do with the windows. That was the single most important move we did to make this project certifiable. So it's not just about saving money. And also looking at, payback, you got to look at the utility costs, and they're different just with everyone we have here in each region of the world. And they're going to change too, so they're not going to be the same. So you can't just look at kind of a short outlook in terms of payback, in my opinion. I know the clients do that, but got to try to convince them otherwise. Yeah.
Great stuff, Harvey. We are going to go to events next, and when we come back, I know Sean Rose has been patiently waiting to ask the question. So Sean, you're up next. First, slap shot from Harvey there. So I think Sean Rose is up. And I will let the questions keep firing away from Shannon. But Marcel, keep it up. Looking fast and furious over there.
Marcel, thank you for the great presentation. It was so much there. I'm going to definitely have to go back to the recording to review that. My question is about that sag that can occur depending on the weight of the facade and the depth of the insulation. Do you have an opinion on how to handle that embedment requirement for steel studs, since there is really no embedment there?
Yeah, that's a tricky one. Maybe it's better to go with a clip and using the each-shot clip, because it has definitely that that structural piece already built into it rather than having a screw. Again, it's an engineering question that I would refer you maybe to RDH structural reports with long screws, where they're looking at a lot of different assemblies as well. I just picked out kind of the wood one for us here that we're working on. So it's definitely possible. It just depends, first of all on the gauge of the stud as well, and then on the weight of the facade. So you definitely can do something to prevent that long-term sag. Maybe by going with a clip or doing the 45 screw angle approach as well.
Right. Great. Thank you.
Great. Thank you, Sean. We also have a question from George McCutcheon, and he asked us to ask it for him. His question is, what consideration needs to be given to the type of preservative treatment that is used for plywood wall strapping, as many types of preservative treatment, except perhaps borate, can destroy fasteners in a short period of time? Is there another reason to use stainless steel?
Absolutely true. Yeah, and maybe not for the structural sheeting because we're typically covered that with our WRB, so it shouldn't be exposed to the weather and the moisture, specifically not behind 6 or 8 inches of mineral wool. But the strapping, right, the wood strapping, definitely. So the old treatment was copper arsenic, I think, for pressure treating, and the copper reacted with the metal in the screws. Also highly toxic. Can you believe it? They used to build playgrounds out of that. Kids, climb on these structures and lick their hands and basically get lower arsenic levels of arsenic poisoning. Well, that's in the past, I think. But so now it's a different treatment, but still there could be some electrolysis issues with the fastener. So stainless will prevent that. The other thing I want to talk about stainless is marine climate. So we have a lot of coastal climates where there is salt in the air. The salt accelerates that, and I'll definitely move to stainless steel if we're close to an ocean. Hopefully that answers the question.
Answer, yeah, excellent. Way to hit to the marine climates as well. So we have someone named Zoom user. Zoom user, would you like to unmute and ask your question? If not, I can ask it for you. All right, time's up. The question is, comments on energy profile of window within external insulation using a wooden buck. Now, personally, I would like to see a thermal break insulation buck, but they were interested in the energy profile of using a wooden buck. What do you think, Marcel?
More of a moisture issue concern for me than thermally, because again, we're in the wet West Coast here, and wood, exposed to that too much, holding a window in place. I wouldn't trust that long term. So that's why we go into something a bit more, non-reactive to moisture and that can't rot away on us. You definitely possible, and I've seen a lot of these approaches in Europe as well on masonry construction. But the more of a low conductive material or even insulating material you can use for that, the better it is, right? So if you have a hard polyurethane type of insulation that holds your window up rather than wood, that's gonna be even better.
Great, and looks like I missed epitane. Do we have someone with that name? Am I pronouncing it correctly? Epatane. I see you're still here, if you can hear me.
I think, yeah, I got it, sorry.
Thank you. Please tell me how to pronounce your name correctly.
No, it's an ID, so I mean, next time I will spell my name, but my name is Elizabeth. So thank you, Marcel, very, very interesting. So I was wondering which, you mentioned there's a software that you use to account for the punctual thermal bridges. You mentioned that it was developed by the Passive House Institute and Andrew Peel. Could it be?
Yeah, it's one of his internal tools that he uses to calculate, especially for screws. But you can use any thermal bridge modeling software to do this. So, the common ones are, well, it has to be 3D. So you have to, because that's the tricky part. It's a chi value, so you'll have to model it in a 3D software. What I'm using is called MoldSim. It's an Italian software that, because I'm running on Mac, so it's the only ones that runs on Mac pretty well. So, and it's not too expensive either to buy. So I can recommend that. It has a 3D component to it. So you can model any clip or any screw or any 3D kind of structural penetration through your assembly with that software. That's the acronym. I mean, Andrew Peel's is more of an estimation or approximation. I don't know exactly what algorithm he used in the background of that. It's an Excel sheet. So, but you could definitely get in contact with him if you want some more information. I'm sure he will be happy to answer. I don't think he's here. He wouldn't answer that right on on the presentation here. No.
He might if he's here. I didn't see him yet, but that
No.
doesn't mean he's not in the crowd. There's a big crowd today. Is it Dartwin, Marcel? I was just trying to look it up.
Dartwin is that's the company, and their product is called.
Okay.
Yeah.
I'll throw a link in the chat for that because it's the first time I've heard about the 3D software for Mac. I've been using
it's great. It's a great
and others, but they're all 2D,
Yeah.
everything I'm using. So I really appreciate that. Thank you.
Thanks.
All right. Next question up
Thank you.
is from Thomas Meehan. Thomas, would you like to unmute and ask your question? Are you still with us, Thomas? Looks like you are. I can ask for you if the cat's got your tongue. What is better, nails of 4.5-inch length or screws number 14, 4.5-inch length for, say, hardy siding boards regarding cost and labor? Boy, that's specific. Good luck, Marcel. You can just say it depends.
Well, nails are really structurally actually pretty good in being more flexible when there is some shifting and stuff. Screws will break just at the tensile strength, or whatever you want to call that. So they have their place, and there's a reason why we nail on hardy siding and not screwing it on, unless it's panels or something. But if you do a regular lap siding, we would always nail that, because it allows for some more deflection to happen. So that's kind of general how I would decide between nails and screws. Well, we don't have 8-9-inch nails. Well, they exist, but that would take forever to nail those through the insulation or strapping on. So we're using screws, also because a screw allows us to shim that strapping in and out a bit easier by backing off or screwing it further in. So that's and there's also structural reasons for that. That's why we're using the screws.
Great.
Hopefully that gets in kind of the realm of an answer.
Yeah, it was actually, I was just going to give you a free pass, Marcel. So thank you. Taking a great stab at that. We have 2 questions left, so buckle up. We're going to get to the final moments of today's presentation. Next up is Ben Station. Ben, would you like to unmute?
Yeah. Hey, Marcel, how are you?
Good to see you.
So Marcel is the certifier I'm using on my Enerfit that I'm attempting right now. So, and he also taught me Passive House. So we're starting to go back a ways. I got a quick question about the over insulating and the positioning of the window within the thermal plane. Do you have an idea, or can you talk generally about the impact of centering the window as opposed to just over insulating by a couple of inches? Specifically because I think a lot of us kind of struggle with sort of design versus performance in so many ways, right? And the design aspect of having those thick walls and really deep window wells that sort of mimic the thick walls that are over insulated, the stone walls that you would have in Europe, is really appealing to a lot of people, myself included. So if with a window installation, if you have an over insulation of a couple of inches, rather than pushing it all the way to the center of the thermal plane, do you get a lot of the performance benefits from that, or do you actually have to go right to center in order to see the biggest impact?
It depends. So first of all, it depends on your structure, right? So if you talk masonry, there's no choice. You got to put it outside into the insulation, right? If we're talking wood frame, it's more forgiving. There's more options there. It comes down to constructability, I think, as well. And I can't give you like percentages of effectiveness, but if you have a thermal bridge model, it's easy to play around with some of these options. You can see the impact. It depends on the window frame as well. Some of them you can't over insulate as much as other ones. So that's kind of a key piece in the beginning. If the window is fixed, you may have a fixed frame window. You may have more opportunity to over insulate the frame than an operable one as well. Doing it on the inside versus the outside of the over insulation, that makes a difference as well. So it depends on all these factors. So in the end, I think you're trying to find the best solution for your project, and also the amount of time and money spent to make this detail, more high performance? Is it worth it really? You gotta weigh that out. Are you coming in, a few kilowatts under your 15 or your certification requirements, which is the regular approach? Then why worry to, go to this extent? Obviously around windows, there's not just about thermal performance, there's also the condensation risks, which is built into the passive house standard, which we need to fulfill as well. So guaranteeing that there is no temperatures low enough on the inside of our window component that we can have some condensation at any time in our climates. That's kind of it in a nutshell. So remember that as well. Sometimes we may do things not just to save energy, it's also for the comfort piece.
Right. And I do think that there a lot of people who are into passive house would potentially be people like me who are very into plants as well and looking for spaces to put their ever-growing collection of plants. So that's why I'm wondering about the depth of the window sills there, because it seems like a very good opportunity in that regard as well. So
yeah, definitely. I mean, if you can put it in the outboard insulation, you see with the example I brought how drastic that impact was, right? So, and that's really because we moved it into the insulation layer, and then having the, the wood structure behind it too, that helps, obviously.
Thanks, Marcel.
Okay. Talk to you later,
Yeah,
Ben.
excellent question. Design consideration for those of us plant lovers, and also for those achieving landmarks where you've got a historic facade and they require that placement on the window. So the last question came from B Squared Arch, and they asked us to ask it. So it's a pretty simple over the plate question, Marcel. So first, I'm just going to thank you so much for today's presentation. I know we all learned a lot. We're going to share this many, many times, and we're looking forward to seeing you again soon. So the last question is, what about using wood fiber insulation in our climate? Any experiences?
We used it in different assemblies. So if we're using a deep stud wall, a 2x10 or 2x8, and we would use a thin layer of wood fiber on the outside because of its characteristics of being vapor diffusion open. So it's allowing some drying out potential. I would use it in the same approach like I just showed. Definitely would cover it though with a WRB, so you don't want to expose it to the moisture here we have in our climate locally here. So a slightly different sequencing, but definitely be open to it. And I understand there's now a North American manufacturer. There's one in Canada that's been around for a while in Quebec, and then now there's in I think it's in Maine, state of Maine, that is producing those. So definitely something we're probably gonna try out next. And maybe just to finish off this, I encourage you to try out things. I know we don't want to do that at the expense of your clients, but look at what's out there, what's new, experiment with things that are getting used in larger buildings. Like that's what we did on this job. We used components that typically get used in a more commercial, larger building and not in a single family home, but they still work. So I think you can find some efficiencies and some optimization by doing that. If you're just repeating the same old, you're not gonna, explore options. You're not gonna move ahead and learn things. It's okay to try things, what I'm saying, and please do.
Marcel, as you're talking about excellence and innovation, brag a little. What was your blower door number on this project? And then what was your final certification? Were you close to Passive Plus, or where'd you wind up?
So blower door was 0.03 or 0.33 or something, be precise. And I just got the certification. It's Passive House Classic. We do have some photovoltaic on the roof, but it wasn't quite enough to make it into Plus. And it was certified at 13.8 kilowatt hours per square meter per year. That's
awesome. That's impressive. And then that was mostly because of the form factor of that building, right?
Yes, we're actually, I was, sweating a bit at some point with PHPP because it wasn't that easy to get to it with the 6-inch outboard. We could have gone to 8-inch and it would have been easier, but we didn't want to do that, extra cost and all that. So as I mentioned before, the main move again was, putting those windows into the insulation plane that really saved us and made it possible to certify this project.
Excellent. Amazing job. Thank you for sharing. And hopefully you'll come back. You'll be our repeat offender. No
Oh,
costumes
for
next
sure.
time.
Yeah, my pleasure. I always like it. Great questions, everyone. Thank you, everyone, for listening. It's really fun to be here.
Thank you,
Great
Marcel.
stuff, Marcel. Yeah, thanks, Kevin. Great point too. And again, I think if we look at Marcel's average for his blower door scores, they're pretty much always in the 0.3. And it's again how your team does it. It's always impresses. And being here in North Vancouver, you've got lots of projects that we've been able to see and have socials at. So again, great ambassador for us. And like most of us said, you're the one that taught us either the trade person course or some type of passive house course. So you are again a leader in our industry, and we can never thank you enough. And so we forgot to kind of do the hourly wrap up, but here we are, 15 minutes past the time of the hour. We did the final 15, and from all of us at the Accelerator, we thank you all for joining us today. Thank you for your questions. Thank you for your energy, and of course, Marcel, we're always indebted to the amazing work that you've done. And of course, we hope that other people will go back and see your other presentations, because you're definitely a storyteller. And as we went through today, you brought the technical, the technique, and the technology. So we got our T3, and we hope that everyone will have enjoyable Halloween. Hopefully you'll enjoy heading to the pumpkin patch with your family. And thanks for being nerdy with us. And I will let Shannon say the last final words before Kim hits the ejection button. So take care, everybody.
All right. Thanks, everyone, for coming. A round of applause for Marcel. Have a wonderful Halloween and a great holiday. And we'll hope to see you at FIASCon. Take care, everyone.